Hi children, welcome to our class. Last class we have seen that polyatomic ions there, radicals there, ions there, and what are the rules for writing the chemical formulae. Today we will see what are the steps needed for deriving that chemical formulae. One by one we can see. Taking one example, we can see that, and then a few examples, the derivation of few chemical formulae also we can see. Okay. So, steps for writing the chemical formulae. So, first of all we can take one example. Last class we have seen that the name is given as sodium chloride. Compound name is given the, and you are asked to derive the formula for that compound. So, what you have to do is, first of all, from the name you have to identify the metal first. Which is the metal? Right, it is sodium. So, first you have to write that, identify the metal, and then you write the symbol of that metal. First you identify the metal and write its symbol there. Then the non-metal chlorine, it is name is chloride, but the non-metal for that is chlorine. So, we have to write that chlorine there by leaving some space. Okay. Then next step, below that we have to write the valency for sodium. Valency is 1, and also for chlorine valency is again 1. That is the second step. Step 1, we have to identify the elements present, the metal or non-metal, and then you have to write the symbol, and then you have to write the valencies below that symbol. Then the third step, you have to cross over the valencies, and before crossing over, if there is any common factor, that you have to divide it. With that common factor, you have to divide that valencies of both the elements and make it symbol. After that, you just cross over the valency, so that you will be getting that chemical formula. Here there is no common factor, and we will just cross over that. If there is no common factor, we can go to the next step, and here we will be writing it as Na1 and Cl1. When we are writing that chemical formula, we should not leave any space in between them. It should be very close to each other. It's a compound name. So, it's a symbol of a compound, and so you have to write. And this one is coming below that sodium, and this one is coming below that chlorine. And as it is 1, for 1 and all we will not write. If it is more than 1, we will write it. Okay. Clear? So, what we will write next thing is NaCl. Both are 1, so we are not specifying the one there, we are just omitting one there, and we will be writing as NaCl. Okay. One next example we can see, the second one is calcium oxide. Calcium oxide, I am reminding you children, you have to by heart the symbol and valencies, then only you can use it here. Next compound given to you is calcium oxide. What is the symbol? First of all, you have to identify calcium is the metal there and oxygen is the non-metal. So, first you write the calcium symbol Ca, and oxygen, what is the symbol? O. And then you have to write the valency of calcium. What is the valency of calcium? You don't know, you don't remember it, you haven't studied. Please study it properly. The valency of calcium is 2. And also for oxygen, it is again 2. Both are bivalent ions. Here comes the common factor. This common factor 2 is there. So, what we can do is, we can divide with the common factor 2. So, here I am dividing with the common factor. So, after dividing, I will get the 1. Okay. After getting that symbol 1, we can cross over it. After getting that smaller number, we can cross over it. So, what we will be getting? Ca1O1. But as it is 1, again we will not write it. We will write it as CaO. So, what is the formula for calcium oxide? Ca KO. Hope you understood. If there is common factor, we have to divide with the common factor. After that, cross over it. Okay. The next one we can see, it is magnesium oxide. Few examples we can see. Magnesium oxide. Which is metal here? Yes, magnesium, and oxide is oxygen. So, we will write the symbol of magnesium Mg first. Then oxygen O. What is the valency for magnesium? It is 2. And for oxygen, it is again 2. Here also what we have to do? Yes, we have to divide it with the common factor. So, we will get 1. Okay. After dividing with the common factor, we have to cross over so that we will get the formula as MgO. That is the formula for magnesium oxide. Okay. Now, we can see one more example, calcium chloride. Calcium chloride. Calcium chloride, how will I write? Yes, Ca. You know Ca is 2. Chloride, Cl, it is 1. So, there is no common factor. So, we will be crossing over it. Then, we will get Ca1. 1 we will not write. Ca. Then, Cl, for that 2 is there. So, we will write it is Ca. Cl2 will be the formula for calcium chloride. Okay. Clear? Then one more example we can see, that is aluminium oxide. Aluminium oxide. Aluminium oxide, how will you write? Yes, aluminium it is Al and oxide is O. Aluminium valency is 3 and oxygen valency is 2. There is no common factor, so crossing over, what you will get? Al2O3. Okay, now can we check that balancing of the ions? See, first rule for writing the chemical formula was to balance the ions or charges present in that. We can see Al is 3 plus, isn't it? So, 2 Als are there, so 6 plus will be there. Okay, and then for oxygen, for a single oxygen, it is 2 minus, right? For 3 are there, so 3 into 2 minus, so you will get 6 minus. Both plus 6 and minus 6 will be 0. That is what I told in that charges should be nullified, or we have to balance the charges on them. Clear? Okay, this is the formula for aluminium oxide. Now we can see some polyatomic ions. Okay, potassium hydroxide. Potassium hydroxide. How will you write that potassium hydroxide formula? Potassium is K. Hydroxide, what is the symbol for hydroxide? Yes, it is OH. Isn't it? And you have to write that for valency. The potassium is 1 and OH is also again 1, crossing over. We will get KOH. As OH is there and its valence is only 1, so we will not write in the bracket. That is the rule, third rule. If it is more than 1, we should represent inside that bracket this ions. That we will see. Okay. Second one we can see, that is calcium carbonate. Calcium carbonate. How will you write calcium carbonate? Calcium carbonate. Calcium is Ca. Carbonate is CO3. It should be written in same size, carbon and oxygen. And valency for calcium is 2, and for carbonate, if you don't know, go through the table and tell me carbonate, what is the valency for carbonate? Yes, it is 2. So, there also common factor is there. So, what you will get? 1. After dividing, you will get 1 each. So, what you will get that formula as CaCO3. This is the formula for calcium carbonate. Now we can see another example, calcium hydroxide. Calcium hydroxide. What is the symbol? Ca. Hydroxide OH. Ca, what is the valency? 2. Hydroxide 1. So there is no common factor crossing over. Ca is 1. So no need of writing that 1 there. But OH 2 is there. So that O and H should be written in bracket. That is what we are telling. Polyatomic ions should be, or radicals should be written inside the bracket and valencies of outside. So CaOH twice. We will be calling it as OH twice. If it is 3, thrice. Like so we will be telling. Okay. Now you understood? Okay. Now we can see one more example. For that we can say ammonium sulfate. Ammonium sulfate. Ammonium sulfate we can take. Ammonium. What is the formula? Symbol NH. NH. Okay. NH valency is 1. And sulfate. It is sulfate. So SO4. You have to see what is here. Sulfate is SO4 and its valency is 2. And there is no common factor. So crossing over you will get it as NH4. That 2 will come for NH4. So what we have to do? NH4 should be written in bracket and 2 should be outside. So NH4 twice SO4. SO4 is only 1. So no need of putting it in bracket. So the formula for ammonium sulfate is NH4 twice SO4. Okay. Hope you understood the derivation of chemical formula. First you will be getting the name there, and from the name you have to identify metal and non-metal. Then you have to write the valence symbol there. Then you have below the symbol you have to write the corresponding valencies, and if common factor is there you have to divide it with the common factor. If there is no common factor you have to cross over and write. If polyatomic radicals and ions are written, should be written inside the bracket, and if it is 1 there we can omit that 1. Okay, more examples are there with your notes. So please go through that. I hope this much is clear to you. Thank you.